Alright, I'm going to continue this equation, or solving this system of equation. I'm going to rewrite the system right here, the two new ones that I have, just so I have more room. Now obviously on both of these I'm going to have to multiply by kind of sucky numbers. So I'm going to try to eliminate my y's because the y's have smaller numbers than the x's, so that gives me a smaller number to multiply. So in order to get these to match, I'm going to multiply everything in here by 6. So 684 plus 6. And then I'm going to multiply this whole row by 37. 37 times 61. Great. Seven times 6, 42. Plus 37. So this is going to be plus. I already know that 6 times 37 is 322 from the last one. 323 times 37. Okay, now I'm going to subtract again. I'm going to subtract up so that I have positive numbers. So these are going to cancel out. So I have 1,573x equals 7,865. Now I need to divide. Great. This seems like fun. Good thing we're not allowed to use calculators, huh? What number can I divide both of these by? Well, if I double this, it's going to be 3, 4, 6. That's doubled. If I double that again, it's going to be 6, 2, 9, 2. That's close. Plus that. Okay, so this equals 5. So we got the x. X equals 5. That's the first step. The next step, I think we're on step 4. Step 4. Plug solution into new equation. And you can pick which one. Remember, my two new equations were these guys right here. I'm going to pick the bottom one because the x has a smaller number to multiply by. So 61 times 5 plus 6y equals 323. 61 times 5 is 305 plus 6y equals 323. Subtract the 305. 6y equals come on, Lothamar. 18 divided by 6, y equals 3. Step 5. Plug both solutions into original equation. Again, you can pick which one you want to use. I'm going to use whichever one's going to be the easiest, so I'm going to look back to my original equations. I'm going to use the bottom one because it has the smallest numbers. I could use any one. X was 5, y was 3, so I'm going to do 5 plus 3 times 3 plus 5z equals 19. 5 plus 9 plus 5z equals 19. 14 plus 5z equals 19. Subtract the 14, 5z equals 5, z equals 1. Remember that we're looking for a point, so our point is 5, 3, 1. And that's the final solution to that guy. It does take a long time, it is a lot of steps, but that's how you're going to solve these guys out, okay? I'm going to do one more. Hopefully I can do it a little bit quicker. If you need help, bring your questions to class, or you can email me. Oops, that's minus. And these numbers are a lot smaller, so it's going to be a lot easier. So I'm going to try to get rid of my z's. I'm going to pick these first two. Actually, I'm going to get rid of the y's, and I'm going to pick the first one and the last one. I did that because the y's already match. So I just have to add these together. 4x plus negative 2x is 2x. Negative 2y plus 2y cancels out. 4z plus negative 6z is negative 2z. 8 plus 4 is 12. Now I'm going to pick the first one and the second one. In order to get these y's to match, I'm going to have to multiply this by 2. So I'm going to get negative 6x plus 2y minus 2z equals negative 8. And again, I'm going to add them together. 4x plus negative 6x is negative 2x. Negative 2y plus 2y cancels out. 4z plus negative 2z is 2z. 8 plus negative 8 is 0. I'm going to take my two new equations and combine them to eliminate one of the variables. They already match, so I'm just going to add down. Negative 2x plus 2x is 0. 2z plus negative 2z is also 0. 0 plus 12 is 12. Now, we had this kind of situation before. All of my variables were eliminated, and it gave me a not true statement. So this is going to be an empty set or no solution, okay? If it would have been the same number, 12 equals 12, then we would say all reals, but this is never true. So that's it.